Hi class, let's take a look at this problem here. We have four groups of four wealthiest people, 40, 27, 26, and we're basically sampling in sizes of 2. So basically these are the 16 pairs that I can have. So now let me go ahead and compute the average of each of these. And I'm just going to I'm using Excel because this is probably the easiest way to do it. And just copy this down the page like so. So these are the averages. So now what I can do is I can just make a tally. So for the answer of 40, as you can see, I have 1. 33.5, as you can see, I've got 1, 2. Looks like 2 responses with that one. The next one is 33. And as you can see, I've got 1 answer, 2 answers there. The next one is going to be, let's see here, 25, and again I'm just kind of going down the list here, and then for 25 it looks like I also have 2 responses. The next one answer that I have not captured is 27, and it looks like there is 1 response that is 27 based on what I'm seeing here. 26.5 looks like I have 2 responses here for 26.5. 18.5, it looks like I have 2 responses here for that one. 33, I've already got. 26.5, I've already got. 26, no, I haven't done 26 yet. So 26, and it looks like I have 1 that's 26. 18, I haven't done 18 yet, and it looks like I have 2 of those. The next one is 25. I've already done 25. And then 18.5. I haven't done 18.5 yet. So it looks like there's 1 of those. And then finally, it looks like 10 is the last one. So there's 1. And if I add up all these counts, I better get 16. And it looks like I got 17 here. So somewhere I made a mistake. So let's go back through. And let me mark these as I go. There's 140. There's 2 here that are 33.5. There's 1, 2 here that are 33. Okay. There is 1, 2 here that are 25, and I had 25 here. I see 1 here that is 27. So there's the 27 right there. And let's see here, 26.5. I have 2, 1, and 2, so that was taken care of. 18.5, I see 2 here, so there's 2 of those. And then 26, I see only 1 response here, and so that was taken care of. Okay, and then 18, it looks like I have 2, and then 10, I have 1. So indeed I have 16 responses here. So somewhere in here I made a mistake here. The sum should be 17. So let me look again really carefully here. Apparently I'm missing something here. So let's look at 33. Let me color code these differently. Maybe that will help me find it. So there's 33.5. 33, I have 2. So let me color code this differently. Okay, 25. 25 is right here, so let me color code that one blue. Okay, 27, there's only 1, so let me color code that one. 26.5, and I think I see my error right now. Okay, finally. No, I don't. 18.5, there are 2 of those, so make those brown. 33, I've already captured that one. 26.5, I've already captured that one. 26, there should have been 1 of those, and indeed there is. And I got that one. 18, I have 2. And I see the issue right here. Do you see it? I counted 18.5 twice. Okay, so if I remove this entry here and then move this up, okay, now finally I'm at 16. So now let's find the probability. So there's a total of 16. So that was a good exercise to kind of check. Okay, so now take each of these values here and divide it by 16 to get the corresponding probabilities. So let me copy these down the sheet. Okay, and I can do these right over here let me see if I can get everything on one page here so you can see everything. So for 40, the probability is 1 over 16. For 33.5, the probability is 2 over 16. So let's do it this way, 2 over 16. For 33, the probability is again 2 over 16. For 27, the probability is 1 over 16. For 26.5, the probability is 2 over 16. For 26, the probability is 1 over 16. For 25, the probability is 2 over 16. 18.5, 2 over 16. 18, 2 over 16. And then finally 10, 1 over 16. So this is the probability distribution. So let's check it, and indeed I got it. So now what they want me to do is find the mean of the population, and we want to compare that to the mean of the sampling distribution. So the mean of the population, so 40, 27, 26, and 10. And if I take the average of those, I get 25.75. So 25.75. And now it should be equal to, okay, because I know the mean is an unbiased estimator. But let's actually calculate this. So to find the mean of the probability distribution, I take each value and multiply it by its corresponding probability. So that's going to be 40 times the probability here. And now let's copy this formula down the page and add all these values up to get expected value, which is a method that we've been using for several weeks now. And as you can see, I got 27.5. So let me do it over here for the population just so you can see that indeed it is the same. And as you can see, it is. And the mean of the samples is also 27.5. And okay, so do the sample means target the value of the population mean? So the answer is yes, they do. Okay, in general, sample means do make a good estimate. Okay, we know that mean is indeed one of the few unbiased estimators that we have. Thank you.